this video, we're going to have a look at speed. Speed is an example of a rate. It measures the distance an object travels for a given period of time. There are two types of speed we refer to: constant speed and average speed. If the speed of an object does not change over time, it is travelling with a constant speed. For example, if a car travels 100 kilometres in 1 hour, it would then travel 200 kilometres in 2 hours and 300 kilometres in 3 hours. This would be graphed as a straight line or a linear function. Average speed. When we drive a car or ride a bike, it's unlikely that we'd travel at a constant speed. We'd speed up, slow down, or stop at traffic lights. So the graph could look something like this. If we travelled, let's say time again is in hours and distance again is in kilometres. If we travelled, say, a total of 30 kilometres in 3 hours, we would say our average speed is 30 kilometres per hour, even though we may have travelled a lot faster or a lot slower in that hour. The speed of an object is the distance travelled divided by the time taken the object takes to travel that distance. For example, a runner takes 3/4 of an hour to run 6 kilometres. What is the average speed? Speed equals distance divided by time. Here the distance is 6 kilometres and the time is 3/4 of an hour. 6 divided by 3/4, just coming over to the side because I've run out of room, is the same as saying 6 multiplied by the reciprocal, 4 and 3. Using some cancelling very quickly, I can see it's 2 times 4, which is a final answer of 8 kilometres per hour. That is, travelling 6 kilometres in 3/4 an hour is an average speed of 8 kilometres per hour. We could also use the unitary method for this problem, and I'll just do this over here because I've run out of room. 6 kilometres is equivalent to 3/4 of an hour. Let's take it to 1 hour. We'd multiply by the reciprocal 4/3. 6 times 4/3, which we worked out before, was 8 kilometres. So we can use the unitary method or the formula speed equals distance over time. Let's take a second example. A cyclist rides 15 kilometres at an average speed of 12 kilometres per hour. Here we've been given the speed. How long does the ride take? Let's just use speed equals distance divided by time and fill in what we know. The speed was 12 kilometres per hour. The distance was 15 kilometres and the time is unknown. Now, rearranging this formula, we would find that the time equals the distance, 15, divided by 12. 15 divided by 12 can simplify to 5/4 or 1 1/4 hours. Again, we could use the unitary method to solve this problem. 12 kilometres is equivalent to 1 hour. Now let's take it down to 3 kilometres because that's going to then easily multiply by 5 to get the 15 kilometres rather than taking it to a unitary method. So 12 kilometres divided by 4 will find the rate for 3 kilometres. 1 hour divided by 4 is 1/4 of an hour. Now we need to know what 15 kilometres, so we can multiply 3 by 5 is 15 kilometres, and 1/4 of an hour times 5, we'd get the 5 1/4 hours, or again we could change to a mixed numeral of 1 1/4 hours. So therefore we could see that time equals the distance divided by speed, which is rearranging this formula. In our final example, a car travelled at an average speed of 50 kilometres per hour for 4.5 hours. How far did it travel? Again, we've been given speed. Speed equals the distance divided by time. Putting in the information we know, the speed was 50, and I'll just shuffle this down. And the distance is our unknown, and the time was 4.5 hours. Rearranging this formula, we can see that the distance equals 50 times the 4.5, which would equal 225 kilometres. Therefore, distance equals speed by time. So that was again rearranging this formula. So we can rewrite this as time equals distance divided by speed. Cut that off there. Or distance equals speed times time. That's just a rearrangement of our original formula. Again, we could solve the last problem using the unitary method. That is 50 kilometres is equivalent to 1 hour, and we needed to know 4.5 hours, so multiplying by 4.5, 50 times 4.5 is 225 kilometres in 4.5 hours. So you have a choice again of using the formula or the unitary method. That's a nice quick summary of speed calculations.